So from this video, we will be discussing on modeling a 3D frame, right? So actually, yes, it's one story for this. If you want, you can. I will show you how to deal with several stories as well. So first thing is you need to go with file and model, right? So that as I don't need to save anything. Sorry, don't need to save anything. Okay, so new model. So you can see the 3D frame is also all there, right? So we need to model if you need grid structure, let's say grid. So you have several grids and six likewise. You can there is a grid, right? So but drawing in this is not easy, right? Not easy means for a beginner it's not easy. If you take a plane and you can draw on that plane and copy it to other planes, that's something, right? So let's say like this. So I'll draw something here, right? And this one here. Okay, so I can copy this small frame in y direction, right? Y direction, I need to know what is the distance. So I didn't see the distance, so it's 0 0 0. From here you can see the coordinate. When I draw, place the cursor, it's 0 0 0. Here it's 0 6 0. So that means this distance is 6, right? So I just need to select this entire frame, because other things is access and other things, so you can edit. So copy means replicate. Okay, replicate. From this replicate option you can copy anything, right? So replicate. So I need to linear, right? Linear. If you want radial, and you can even mirror images, right? So you can check these options later. So I will linear. So I need to do it in y direction. So the increment is 6 meters, right? Increment is 6 meters. I need to copy it 3 times, right? 3 times, right? If you add x distance as well, so it will go 6 here and in the x direction as well, right? Okay, so wait a minute. So if you want, you can copy it in y direction as it is. So you can see it gets copied 3 times, right? So if you want to undo it, I think there's you can, I think control is set. Yes, control is set, undo. Okay, you can undo it. So, and if you need this to be copied, let's say in diagonal direction, let's say it's 6, and x direction it's 6. So it's not this frame. Even if any element, you can copy it like this, right? Okay, if you want, you can copy it in the vertical direction, Z. Okay, so modeling this is not hard, but for a beginner I recommend you to use this frame option. Okay, 3D frame, and you go with this. So number of stories means, so you can see this is x direction, this is y direction, this is z direction, right? In the x direction there are 3 bays, right? Base means number of these segments, right? So and the number of segments in y direction is 2. So you can see 2 and 3, and story height is 3, right? So this height is 3. So number of stories 2, right? So in the question given to you, it says 9. So 9 bays, 3 segments in x direction, 3 bays in x direction, 3 bays in y direction in that case. Okay. So I will only model 5 bays in x direction. Okay, 5 bays in x direction, and that bay width is this length. Okay, bay width is, I will select 6 meters. So 6 meters is okay, just fine. And number of bays in y direction, I will call 4. Okay, not 4, I will say 3. Okay, so bay width is, I will select y direction, just 2 meters. Okay, so in such case, so what you need to do is, you can, yes, number of stories 1, story height is, usually your story heights around 2.5 to 3, right? So I can select 3. Okay, so if you want, you can use materials from here for beams and columns, but I will do it later. So to just keep it default, right? So restraints are there, right? So it will apply some restraints, right? So this is an open frame building, right? If you want, you can, there are several options, other options as well, perimeter frame building, beam slab. So you can just go through that later. So this is my story height is 3. It's just 1 story. Number of bays in x direction 5. Number of bays in y direction is 3. Bay width is 6 in x direction. Bay width is 2 in y direction. So it just okay. Can you see? So this is this is a frame I got. No, I don't think this is. I will select that. I will delete that again. Not, it's just unusual for me. So I will use number of stories 1. So story height is 3. Number of bays in 5. This is 6. That's okay. This is going to be 3. So bay width is bay width is also 3. I will select, and I will select 4 bays. Okay, so that's something longer in y direction as well. That's okay, that's fine. It looks fine. Okay, so all the so if you select this joint, you can just see what's the joint there. So they have an so it's initially pin. Okay, you can see that triangular shape. So you can, so what you need to do is select these joints. So if you select like this, all of these joints will be selected, right? So in order to do that, just let's clear all, and you can just rotate this. Okay, rotate this until it's get like this, right? So you can now click each joint, because the other joints are in first story, right? Those are not selected when I click like this, right? Exactly, those, all the joints should be in this rectangle, right? That's how you select it. Even if you can select it from the view, set 2D view, right? XY plane, no, whatever, right? YZ plane, okay, like this. Okay, sorry, XY, like this. But if you choose like this, it's only 2D. We are in this plane. Can you see? It's get blue color. We are in this plane. Okay. If you want to move that plane, you can use this arrow. Can you see? The blue line is here. Now we are in this plane. Select, there will be a light blue line here. Okay. Can you see that blue line is moving? Again, click. Now we are in this frame, right? So it's better you can see it in 3D. So, right? So the easiest way is you can clear all. So in order to, you just like this. So it's still in 3D. So once you click this rectangle, everything will be there, right? Otherwise you will have to use one by one, right? So even if you can select a plane, it's like XY plane. So now we are in 2D plane, on this plane, not the lower story. So if you select these things, only the joints in this plane will be selected, right? If you are in 2D, your selections will be done according to that, right? If you are in 3D, whatever you selected, you should be careful, right? So I will select. So from this plane, I will go to the lower flow. So now I'm in support level, right? Go 3D. So now I'm in support level. Okay. So can you see that I'm moving the plane? The blue plane is showing where I am. Okay. Now I'm at bottom. Now I'm at top. Now I'm at again bottom. Bottom. If I need to select the supports, I can simply select all the things selected and then assign joint restraint. So I will keep it all everything pin. Okay. When you pin it, rotations are allowed, but translations are restricted. Tick means restricted. Okay. So it's already been there, nothing to be changed. And again, this 3D view, clear all. And now my frame is there. I need to define columns, right? I need to define columns and beams with the material. So I will apply different materials this time. So material, I will copy this, not different material, different sections. Okay. So module, I will add a copy of this material. This is concrete. So there are different grades, grade 30, 40. Likewise, you can define it from the here. So weight per unit volume, I will say 25 with the reinforcements, right? The original density is 24 around something. With steel reinforcement, it can be nearly around 25. So this is just to our model follows the exact conditions, right? If you know the modulus of elasticity exactly, you can substitute it here. I will say it's 0.15. Other things are okay. If you, most of the times you only need to define this and weight per unit volume. That's only, right? And yes, it's done. Concrete. It's there. So I need to define beams and columns. So I will go to section properties, frame sections, and yes. In this import, not import. If you know it to import, you can import. Okay. So I'm going to add new property. So that's going to be here. Concrete is not the same that we defined earlier because this is a default section. Okay. Don't worry, I will edit that name. Otherwise, it will be confusing for you. Concrete. Not material concrete. Okay. So this is going to define sections, frame section. I need to it's not steel, concrete section, rectangular, right? So there is also 2 and 3. So you need to determine what is 2 and 3. There will be third and second axis. Okay. So okay. So then for this is for beam. So all the beams I will apply this section. It's going to be, let's say, depth is depth is, let's say, point let's assume how much. Width is 0.2, depth is 0.3, width is point, so depth is 0.2. Okay, so that's something like this. Okay, usually it should be other way around, because your depth should be larger, because the deflections, when you calculate I value, it's BD cube, right? D to the power 3, depth to the power 3, right? So if the depth is large, your deflection will be smaller, right? Compared to the width. Okay, for this I will just use this, but you should know the fundamentals, right? So usually it's other way around, your depth is normally larger, right? Then I will use beam sections like this. No, I will just use again correct way things, otherwise it would be confusing for you guys as well. Depth 3 and width is 0.2. Now it's okay. The material is matcon, right? So if you need to determine the section properties, you can go. You don't need to calculate anything, it's given. Okay. If there are no material, no any units are given, so you have to address to these units. Okay, so it should be m to the power 4, right? And yes, it's okay. Yes, you can go with that. You don't need to adjust these reinforcement, that's unnecessary for this stage. Beam, this is 300 into 200, right? Okay, yes, okay. Then you can add a copy of that material. This is column. So columns I will take 300 into 300. Okay, that means width is also 300. So material is there, right? Section properties you can calculate from here. Moment of inertia, third axis, second axis, everything is there, right? E value is there in the material. You remember? E value is here, right? If you want, you can edit that E value, something like a round number, right? So column is okay. Column is done, right? But still we have to assign that, right? We have to assign those values. So how we are going to do is, so we need to separately determine the columns, right? To separately select the columns. So how do I do that is, I can rotate this view. So if I select from left to right, so you remember it's like AutoCAD. There should be only full element. There will be only full element getting selected. No full element, I think, will be selected. Can you say? But right to left, anything in the box will be selected, right? All the columns are selected. You can see from this view, right? So that's for those selected columns, I can assign frame sections, then that's the column, right? So we model the columns and we apply the correct section with the material, right? That's column, right? And now all the things are deselected, so I can again, so beams, then I can select this top floor with left to right, because whole thing is getting selected. Can you see? All the beams got selected. If I select it the other way around, columns will also be selected like this. Can you see? So you can't assign. So clear it and left to right. So you can assign frame beams B. So you can see beam material is, so if you want, you can see whether my materials and sections, so section is there, right? So it shows the section. Within the section, I have defined the material and e-value, everything is there, right? So now my frame is fundamentally okay, right? If you need, you can extrude the view and sheet. So this is my frame, okay. Okay. So I don't need even local axis. Local axis 1, 2, 3 axis is there, so you can follow that later. I don't need that now. And I don't need the sections as well. Label. So label is automatically there. I don't need it. Yeah, it will be. It will get disappeared in the next step. So I'm not going to model this slab, right? There are a couple of reasons, right? If you model the slab, this will be a rigid diaphragm. So rigid diaphragm means if you model the slab and the beams, everything is connected. So that slab with beam moves laterally together. That's a rigid diaphragm, but now it's not connected. For instance, this joint can move relative to this joint, right? I don't know, right? In that case, you have to model it and select a rigid diaphragm, right? In the MIDAS, if you say MIDAS, there are options to select rigid diaphragm. In such case, you need to draw a sample slab and then it will be a rigid diaphragm because everything is connected together. It will move laterally. So one thing is how to idealize the real condition to the mathematical model, right? So the FEM model. Now I need to, so the material is okay. So because I need to manually analyze this using a simple frame, and so therefore I will just neglect the self weight and define a load pattern dead. I will call this unit dead. The reason I check it unit dead is will be told later. Self weight multiply 0. I don't need to include self weight for that, right? It's a dead load and add it. And then unit live load. It's a live load and self weight multiply 0 and add it. So add new pattern, right? Dead and unit live is there, right? Sometimes this unit live not be needed. Even unit dead is fine. So yes, I will call this unit dead. This is not needed, I think. One unit load is fine. Modify unit load. The type I will say dead load. During the combinations, you can define it in a different way, right? I will teach you how to do that. That's okay. Then modify, select modify. You have to modify it unless it's not getting modified. Okay, right? So still the materials are there, self-weight are there. So one thing is the load patterns you define are coming into play when you analyze it. You analyze it for the load patterns you define. So if you analyze for that unit load, you will not consider any of the self weight. So if you want, you can analyze that both dead and unit load, right? So one with self weight and the other one we did not have any self weight. And the one where we define any external load, we define it using load unit load. Then it will be easy, right? So what I need to do is I need to add this. So there will be basically slab load and the live load, right? Weight of the slab and the live load, right? So we will just neglect partitions or any other finishes, right? So I can add dead load of this slab and the live load, right? So for the slab, I will just consider 150 millimeters thick slab. Okay, so I need to calculate that values. So I will go to analysis. So you can see. So my slab was, I didn't model the slab, right? I didn't model the slab. My span was one, if I select one particular panel. So this was 6 meters and this was 4 meters, right? So this is Lx and this is Ly. So I need to determine whether this is two-way or one-way, right? So Lx over Ly is going to be 6 over 4. So 1.5, right? So it is less than 2. That means this is going to be two-way slab, right? If it is larger than 2, so that means this is considerably long. So that means more portion of the load is taken by this longitudinal beam. So that is one way, right? So in such case, we can do is we can draw a line from 45, from 45, 45, 45 degrees. Okay, this is approximately load distribution. Okay, if it is 45, right, this will be 2. I will draw it another way. Right, it's 45, angle is 45. Okay, angle is 45 and this length is 6, this length is 4. That means this length is 2, this length is 2. Since this is 45, this is also 2, right? This is also 2, right? This is also 2. So this is the load taken by this beam, right? This is the load taken by this beam. Right, that height is 2. Let's say I will apply a unit load 1 kilonewton per meter squared, right? So we already have 24 meters squared, this panel, right? So if I multiply these, I will get 24 kilonewtons, right? Okay. 24 kilonewtons acting on this panel, right? So that means per each unit meter squared, you have 1 kilonewton, right? That's it. So 1 kilonewton is how much? So a cement bag is 0.5 kilonewtons, right? So 1 kilonewton is 2 cement bags in 1 meter. Always just have an idea how much load is actually there, right? So if you apply like this, so this part is the trapezoidal UDL acting on this area, right? So you can just, so this height is, because this area is 24, right? Area is 24 and now total load is also 24, right? So that means this height is the actual height of that UDL, right? This height is the actual height of UDL acting on this beam, right? If it is 2 kilonewtons per meter squared, it is going to be 42, 48. And that means your load is 24. That means this height should be multiplied by 2, right? So whatever you apply, that's why the advantage of a unit load. If you apply a unit load, right, this height is the height of the UDL you have applied, right? There's already 1 kilonewton. If you apply 1 kilonewton per meter square to this slab, 1 kilonewtons per meter square, these are the loads that you have. On this beam, you have a UDL like this. On this beam, you have a trapezoidal UDL like this. This side is also 2, right? This length is also 2. This length is also 2. This length is 4. This length is 2, right? So if this is for a unit load, right? So what happens if your load, let's say your unit live load is 2.5 kilonewtons? So you just need to define you just need to multiply each by 2.5, right? So that means your live load is now added, right? So that means these will be automatically multiplied by 2.5 and this UDL will be multiplied by 2.5. So that's the advantage of the unit load, right? So let's say our slab is 150 millimeters thick. 150 mm, right? So then what you have to do is you have to calculate the load per unit. So this is, the density is 225 kilonewtons per meter cube. So I need to multiply it by the thickness. Then I get the load per unit area, right? This is 0.15 meters. So when you multiply it, you will obtain 25 into 0.15. It's going to be 3.75. So your dead load of the slab is 3.75. Remember, just remember, we have neglected the weight of the beams and columns, right? That is initially modeled. We are not modeling the slab. We are giving the weight of the slab. So that is already now in the model. But we model the beams and columns, but set the self weight to 0. That means the results we are taking only resulted from the self weight of the slab and the live load on the slab, not the weight of beams and columns. If you want, you can set that self weight multiplier 1. Okay, then that's done, right? And sometimes people do, for considering beams and everything, they multiply this by 1.1. How this 1.1 is that they consider this is around 10% of the total dead load, additionally 10% beams and columns. So then they multiply this. Okay, so if you want, you can do this. I'm not going to do in this example. So my weight of the slab is 3.75 kilonewtons per meter squared, because this is meter cube. Okay, so 3.75 and my live load is 2.5. First, I'm going to, so this is the UDL, you need to apply it, right? This is the UDL you need to apply into the each beam. 2 is the height, this length is 2, this length is also 2. Sorry, this is I think 2, right? It's 1/3, 2/3, and the remaining third, right? 2, 2, 2, right? Here it's 2 and height is 2. So if I apply a unit load, the UDLs will be like that. So then I'll go to SAP, right? So I will apply. So these longitudinal beams will be getting that load, right? So I will take that frame. So I need these beams first. I need to select this, right? So that's left to right you are selecting, right? So then 3D. So these beams get selected, then assign. So beam sections you also already assigned. So frame, so because this is a frame, then distributed load. So I need to apply a trapezoidal load. So at 0, you remember load was 0. At 2 meters, absolute distance, at 2 meters, right? Absolute distance, and 4 meters and 6 meters, right? At 2 meters, load was 2, right? The height of that trapezoidal is 2. Because what we are doing is we apply a imaginary unit load and get the resultant UDL, and then we apply that UDL to the beam. And then for the loads you actually have, you only need to multiply it by that value. That's it. 2. I think this is going to be okay. It's in gravity direction, coordinate system global, that's why gravity. Okay, if you say local, that's in local, you have to check the direction. It's not dead, it's unit load, right? It's unit load. It's our pattern we defined, right? Can you see now? It's okay, right? So I need to select the beams in other way around. The best thing is I can draw this, right? Okay, so then I can assign it's a frame load, right? Distributed. Always know what you are doing. It's a unit load. So to replace, I didn't have any load in there, right? Initially, because these are the secondary beams. So global, it's okay. So from here, you only have just, you don't need this. Let's say this is let's say relative distance, okay? At 0.5, say 1, okay, 0. Doesn't matter, it is this 1 because our beam now ends from here to here, 0, 0.0, 0.5, and 1. Keep this 1 as there and 0. So that doesn't affect, right? At 0.5, you have a 2 kilo 2 kilo 2 kilonewton height, right? You remember that triangle? Okay. So this is also caused by a unit load in that panel, right? Okay. So that triangle is done. You see that? Now my load is defined, right? But one thing is missing. What's that? So if you consider this panel, load from this beam and load from this beam also get added, right? The same. So load from this panel is also coming to this beam. From this panel is, so for interior beams, not the along the edge, for interior beams, this load will be doubled, right? From this panel and the next panel. So we have to select that. So for this beam, it will get doubled, right? So load from this part and load from this part is added. We only add one, right? Due to a one panel, right? So these are doubled, right? So I need to go to 3D and then assign frame loads distributed. Now, either you can replace, right? Then you can, I will replace it, or else you can add to existing and add the additional value. I will check still replace and absolute distance 246, and it's going to be actually 4, right? 2 plus 2, right? And 2 plus 2 here is also 4, because that's going to be two trapezoids getting I will show you that. So it's like this. It's like this. This is the panel. So you remember this 2, right? This was also 2. This was also 2. Consider these two panels. This beam is also giving something to this beam, right? So actually it's not one panel. So all these will be there on this beam, right? This is also 2. So the total height of that UDL is going to be 0 at the ends, not going to change. But this height 2, this height 2, it's going to be 4. It's going to be 4. And for this triangle, this side 2, this side 2, so that's going to be 4 as well, right? This is only for interior panels. If it is at the edge, only that load will be there. No any panels here and no any panels here, right? This is the edge panel. Edge panels, you only have one contribution, right? So at 4 and 4, that's okay. Replace the existing loads, right? Now it's okay, and I need to select the other way around as well. So this is going to be these beams. Assign frame loads distributed. Relative distance is easy this time, 0. So it's 0.4, 0.5, that means middle. 0.5 means middle. Relative distance. If it is absolute distance, absolute length. Okay. 0.5, 4 meters. That's okay. Right. So now my things are okay. Right. So I have added the unit load. That's what I did. Right. Okay. So now I can define load cases, because not unit load is actually 1 kilonewton is the load we added, but it's not the load we are going to analyze. We are working serviceability conditions. So that means dead load plus live load, right? So define not load cases, sorry, load combinations, right? New combination. I can define slab bait. Slab, that's going to be a unit load. Okay, when I add the unit load, you have already 1 kilonewtons per meter, but the actual load is 3.75. So what you need to do is multiply this by the scale factor is 3.75. So you have the unit load multiplied by, so this is the slab load. This is the slab. Okay. So, and add a new combo. This is the live load. We don't need to define any live and dead at the patterns, right? That's confusing. This way is easy. Even if this case, you remember that unit load was actually a dead type, right? Dead load type, but that doesn't matter. We can define separate cases. Okay, I will show you. And we can analyze this for each combination. So I will, this is also unit load. Okay, no need of unit live load. This is the live load. So we are, for the moment, we have 1 kilonewton meter, and we just need to multiply it by the actual live load. So I would say it's 2.5. Add it. Okay, right? Slab load and live load, you can separately analyze for live load, separately analyze for these combinations. And for the serviceability, I can have a new combination. Let's say serviceability. So I would say I need to apply slab load and the serviceability. You have the slab only, you don't have any factors, right? Slab load is there, the scale factor is 1. Live load is there, scale factor is 1, right? So whatever the slab and live load are acting simultaneously. Scale factors are 1. 1.1 into dead load plus 1 into live load. That's there, right? Okay. So I will define from this and a copy of component and ultimate unit state. Ultimate state. So that's going to be slabs. So ultimate factor is going to be, so dead load, you have 1.35, right? You have to modify it. You select this. Live load, you have to modify. Scale factor is 1.5, because that's going to be dead load into, dead load is a slab into 1.35 GK plus 1.5 QK. So this is our combination ultimately state. So our states are already defined, right? That's why I did not define any other load patterns. So this, even this is dead or live or whatever, that doesn't matter. We are analyzing it for combination. Within the combination, I define those separate cases. Within the separate, this case only have the slab only. This case only have the live load only. This case only have slab and live, but serviceability. This slab and live, but ultimate state with the factors, right? The slab, how we did is we applied a unit load, right? We apply unit load and multiply it by the original value, right? That's easy. So now all the things are there. What I did was I just apply a unit load on this structure. See how that's very easy, right? So now my dead load is not there. You can go ahead and analyze this. So I don't need this model for now. Can run this. So this is 3D frame. Can you see the bending moments and everything is there, right? So once again, I'm not going to give you the forces. If you want a joint reaction, so you can calculate anything, serviceability or ultimate limit state, you can check the reactions. So reactions are there, right? Since this is a pin, they will give 3 reactions in each direction. You have to get these from. If it is not clear, you can go to display, show tables, right? So we are worrying on joint reactions, right? Joint reactions, and select OK. Then it will give you the table, right? Is for slab or whatever, you can sort it. Sort table using anything, right? Right. So you can buy force 1, and likewise you can select it. And then you can even, I think this can be export to Excel. Okay, this can be export to Excel as well, right? So if you show the deformed shapes, so let's say the deformed for serviceability, we usually define it for serviceability. So can you see, this is the shape. In the joints, you will be given the displacements. So displacements are given in these units. Okay, you have to consider what is u1, what is u3, u2. Those are, you need to consider what are these. Okay, yes, then you can go with, I don't know what is this moment, shear 2 to whatever, right? Let's say shear 2 to for the live load only, right? This is shear force, right? So if you need to, just like we did in the previous video, you just need to, if you want this member, you just need to press your cursor and right click it, and that will give you the load, right? And the bending moments and the deflection, everything, right? Okay, and even from here you can change the values, right? And even you can say unit load, right? That will give you the distributed load, shear. I don't know with this M3 and M2. I'm not going to tell you what those, because you have to consider what is the V2 and what is V3 and M2. You have to read the documentation and identify. That's very important, because even if you run it, you can't, even if you can't interpret the results, this finite element is nothing, right? So you have to interpret the results. You have to know what is this, right? So I will automatic. So then you can determine these values when you know the joint bending moments. So one good thing is you can idealize something, a frame like this. I'm showing this frame, and you know the applied loads on that frame. You have to consider that from each of these contributions, you know the loading, trapezoidal loading on this frame, because only on it's on the beams only, and you can manually localize that frame and analyze using any structural analysis technique, and see whether uh, these answers are the same, what's the difference, why is that, what happens there, did we did a mistake, what are the assumptions made. You have to compare and see what happened to the results, right? So that's your second task given. Okay, so this is not, even if you think, even since you have already modeled the loading and everything, right? So you have the loading as well. So now you can even just frame sections, I would say, display. Modeling is very piece of cake, right? So what you have to do is load assignments, frame, load, I would say. So my loading is there, right? So to draw the flows, I only need to copy this flow without these supports, right? Because we can't have supports at each level, supports only at the bottom level. So here joint, so that means I need to copy this entire structure without the support, right? So I can just left click, sorry, make sure no support is selected. Okay, now my every beam and every column is selected with loading. Okay, loading you don't need to copy, because when you select the elements, load is already there, right? So what I need to do is, let's say this is going to be a 10 story. Okay, so I just need to, you can copy it from here, replicate. So in the dx direction, so my story height was 3, right? You remember, in z direction. So I need to copy in 3-meter intervals. So I need 10 stories. So I have to copy it 9 times, right? 10 stories with the loading. So this is going to be your structure, right? And you see, modeling is very easy when you know the concepts and what to do, right? But interpretation is different. You have to know the things, right? So this is 10-story frame, right? 3D frame, concrete building. Actually, you did it, right? It's no big deal. And when you analyze it, I will check these models as well. So we analyze the 3D frame, right? So this is the entire so from here you can analyze what are these models. So I'll leave you to determine what are these modes. So you will be learning those later. So you can see nice animations there, that giving you model and the time and the frequency of that mode shape, right? If it is the second one, mode 2, so that's going to be in the other way around. So this is the frequency and this is the time period. So this is very critical in actually in earthquake designs. So mode 3, your T will be, I think, ready. So that's something torsional, right? It's kind of a torsion. So your T will be reducing with each mode. So this is a complex behavior. So one good practice is usually this first mode time, right? That there are some thumb rules, right? Saying that it should be within 0.1 seconds per story. That means if you have 10 seconds, 10 stories, that your T should be 0.1, exactly 0.1 into 10. That's going to be 1 second. So our period is larger. That's not good. That means our structure is, so what does that fundamentally means is your structure is going to be oscillating for a larger time, right? So T is 1.5 means it's not that much. So you need to reduce T around 0.1 into number of stories. That means 1 second. Okay. So you have to know these things. It's 0.1 second per flow. Uh, it is not needed for now, right? So if you need, you can stop it and analyze the joint reactions as well. Ultimate, so reactions will be there, right? Okay, so let's say if you unlock the model, and let's say you will be removing this part, and continue the rest to another 3 stories. So you have to only delete this, and then with the loading also, that will be get deleted. Okay, then what you need to do is, I need to continue these frames to another 3 stories. So I need to do, what I need to do is simply I select that, it, duplicate. So modeling is an art, right? You don't need civil engineering to model this. It's an art to how to idealize the structure and model it, right? It's easy, very easy, right? So I need to copy it 2 times, let's say. So dz is 3. Okay, so can you see? That's very easy, right? So I will undo this, and if I want to replicate in horizontal direction, I will replicate in horizontal direction. That's going to be x direction, but plus x direction is there, so it's need to be minus x direction. I will say it's 6 meters, right? So I need to place this part to here, right? This part to here, so that I have to move 6. That means 18 minus 18. If your joints are actually there, it will automatically be connected. But if not, let's say your joint is somewhere here and you replicate it to here, so there's connectivity issue, right? So you should exactly know your length and other things, right? Number is 1, right? One time copying is enough, right? So if you want, you can replicate these parts. So that's going to be a completely different structure, right? So you need to edit, replicate in z direction 3, going to be 2 times with the loading, right? So that's why I'm telling you, just apply a unit load and do the thing, right? So that's things going to be very easy then. I think some connectivity issue is there already, right? Wait a minute. Yes, this is not connected. Can you see? I think I have deleted, I haven't selected that when I'm copying, right? So if it is small, you can draw that. But you remember, when you draw it, load is not actually there. So you need to again define the loads on that frame, right? And check the sections as well. Because when you draw it, you can see the section is original FSC1. So if you want, you can select it from here, but you are drawing column, then you draw it, right? But I think I just draw that default section. Okay, so I think now it's okay. I just run it. Okay, so no big deal. So this will be a completely different one, right? Still, the first mode is in x direction. So yes, it's very easy.
So, but this kind of frame, you can't actually do it manually. That's why you need a computer analysis, right? So from software, but if you localize a small frame and if you know the loading, you can still check manually some results, whether this is giving the results we wanted. Whether sometimes you may have applied the same load twice mistakenly. So that's going to be huge over design, right? So that's why I always recommend you check a small thing, right? Even if you can check the axial loads are correct, right? So thank you.